Hi, my name is James Mullen, and I'm here to present our paper, Placing Human Animations into 3D Scenes by Learning Interaction and Geometry-Driven Keyframes. Our goal is to place 3D human animations, like that in the top left, into a 3D scene, like that in the bottom left, while maintaining interactions with the scene that the animation contains. In the animation in the top left, this would include sitting and reaching and grabbing objects into the scene. It's important to maintain these so that the placement looks realistic. Here's an example of our method, which we call pack, for placement of animations with active keyframes. Pack can enable use cases in augmented and virtual reality, game design, and human-robot interaction. For example, an AR designer may want to populate a living room with people sitting on chairs or couches, navigating the space, and having a conversation in the corner. An automated solution like Pack can greatly reduce animation costs. As a key component of Pack, we introduced active keyframes, frames in the animation most important for interaction with the scene, and use these frames to optimize the placement of the animation into the scene. To find our active keyframes, we extract semantic information using POSA, and then feed that output in the animation's geometric information to a deep model that estimates important interactions. We then take inspiration from active learning techniques and use our model's gradient to calculate a diversity score across the animation. This figure shows the examples of some of our selected active keyframes, which appear in green. Note that for the top and bottom left, frames beginning the transition from sitting to standing are selected because they're especially important in getting a realistic placement. First, we want to share some qualitative results. We show Pack against Prox ground truth in 3 baselines, the first of which is POSA T, where we extend POSA to the time dimension, the second of which is the state-of-the-art motion synthesis method, and the third of which is our model without our active keyframes component. First, we're going to show Pack on the left with Prox ground truth on the right. Note the penetrations into the scene on the Prox ground truth video. You can see in the Pack video, the hand is supporting by the bed but not going through it. In contrast to this, the Prox ground truth video penetrates the scene. You can see this person's bottom. Next, we want to show Pack against POSA T. In the video on the left, you can see how well the Pack animation seems to contact the scene, interacting with it in a very natural way. In contrast, the POSA T algorithm does not place the animation in a way that really makes sense with the scene, sitting on the wall and seeming to collide with the objects throughout the scene. Next, we want to frame it with a motion synthesis method and show why we want to use existing animations. You can see, using our existing animation, we have a nice smooth motion that avoids the scene and doesn't have any problems. In contrast, the motion synthesis method here seems to result in a really unnatural looking motion. We also test our method with a perceptual study. This is following in precedent set by the POSA paper. In doing this, we showed raters 2 videos side by side and asked them to pick the video that looked more realistic. We first compared against the Prox ground truth we showed you previously and the same 3 baselines, the POSA T, motion synthesis, and geometric keyframes methods. Raters preferred Pack over Prox ground truth. This is likely due to the penetration we were showing you in our qualitative results. Raters also preferred Pack over all 3 baselines. Motion synthesis was especially unrealistic, framing the need for Pack, a method which places existing animations into a scene, and not trying to create new ones. Pack is also comparable to POSA T and geometric keyframes in the contact score, denoting contact with the scene, and non-collision score, denoting no penetrations with the scene.